Welcome to BSc Main Physics, Semester 6, Paper 1, Solid State Physics, Unit 4, Dielectrics. We continue, and today it is class number S46, Electrical Susceptibility. Electrical susceptibility is the topic of discussion today, and this also you see in electrodynamics. And here we can see what is the meaning of electrical susceptibility. Electric, or we can read as electrical susceptibility. When a dielectric material is placed in an electric field, it becomes electrically polarized. For isotropic dielectrics, the polarization vector P is proportional to the electric field E. Thus, we write P is equal to epsilon 0 chi E into E. That letter, instead of epsilon 0 and E, we read as chi, small chi. Spelling is CHI. Chi E, that is a suffix. It represents electrical susceptibility. Chi E into E. Because in magnetism also there is magnetic susceptibility, we write as chi M. So in order to distinguish, we write here electrical susceptibility as chi E. X പോലെ എഴുതുന്നതാണ്. P is equal to epsilon 0 chi E into E. Here, chi E is the electric susceptibility. Chi E suffix. Chi, the spelling is CHI. Chi is electrical susceptibility. It is a dimensionless quantity and is characteristics of the medium. അതൊരു ഡയമെൻഷൻ ഇല്ലാത്തൊരു അളവാണ്. അത് മീഡിയത്തിൻ്റെ ഒരു പ്രത്യേക പ്രോപ്പർട്ടിയാണ്. This means P is in the same direction as E, and the magnitude of these two vectors have the ratio chi E epsilon 0. അതായത് നമ്മൾ P by E എടുത്താലേ നമുക്ക് epsilon 0 chi എന്നാണ് കിട്ടുന്നത്. So you remember the relation, the polarization vector P is equal to epsilon 0 chi E into E. Chi E is called electrical susceptibility. And there is an important question based on this chi. It is a problem type of question. You see, to derive polarization initial epsilon 0 E k minus 1. K stands for dielectric constant, and we can write as epsilon R. In the place of K, we can write as epsilon R. So this is an important relation for polarization vector P is epsilon 0 E into K minus 1. You remember K is epsilon R, relative permittivity, dielectric constant. The polarization vector P can be expressed as, just we have seen, P is equal to epsilon 0 chi E into E. The constant chi is called electric susceptibility of the dielectric material. And that is equation number 1, is electric field within the dielectric. Then electrical displacement, you know. Electrical displacement is epsilon E, epsilon 0, epsilon E, which can be also written as D is epsilon 0 E plus P. Now substituting equation 1 in equation 2, we get D is epsilon 0 E plus P. P is epsilon 0 chi E into E. Epsilon 0 we can take out, epsilon 0 into 1 plus chi E into E. And 1 plus chi we write as 1 plus chi we write as K or epsilon R. So we get the D is equal to epsilon 0 epsilon R E or epsilon 0 K E. That is epsilon A, epsilon 0 epsilon R or epsilon 0 K is equal to epsilon. This is the permittivity of the medium. Here K is a dielectric constant or relative permittivity epsilon R of the medium. The quantity epsilon is called permittivity of the material medium, and you remember epsilon is epsilon 0 epsilon R. And from equations 2 and 3, we have equation 2 and 3 here in this page. And from this, ഇവിടെ equation 2 ഉം 3 ഉണ്ട്. 2 എന്ന് പറഞ്ഞാൽ ഇലക്ട്രിക്കൽ ഡിസ്പ്ലേസ്മെൻറ്റ് എപ്സിലോൺ 0 ഇ പ്ലസ് പി ആണ്. 3 എന്ന് പറഞ്ഞാൽ ഡി ഇസ് ഈക്വൽ എപ്സിലോൺ 0 കെ ഇ ഓർ എപ്സിലോൺ ഇ എന്നുള്ള ഇക്വേഷനാണ്. അല്ലെങ്കിൽ ഇടയ്ക്ക് എപ്സിലോൺ 0 ഇൻറ്റു 1 പ്ലസ് കൈ ഇ ഇൻറ്റു ഇ എന്നൊരു ഇക്വേഷൻ ഉണ്ട്. ഈ ഇക്വേഷൻ 2-ൽ നിന്നും 3-ൽ നിന്നും നമുക്ക് ഇങ്ങനെ എഴുതാം. From 2 and 3, we can write K epsilon 0 E, that is D. K epsilon 0 E is equal to epsilon 0 E plus P, and you transpose and find P. P is equal to K minus 1 epsilon 0 E. K minus 1 epsilon 0 E, or K is epsilon R. P is epsilon R minus 1 epsilon 0 E. That is the equation. And for vacuum K is equal to 1. And you remember, the polarization is proportional to the electric field because P is equal to epsilon 0 chi E E. Chi E is a dimensionless constant known as electric susceptibility. We have seen electrical susceptibility of the medium dielectric. The constant epsilon 0 is included to make chi dimensionless. The electrical displacement is defined by the relation. Displacement എങ്ങനെയാണ് ഡിഫൈൻ ചെയ്തത്? D is equal to epsilon 0 E plus P. From equation 1 and 2 we get D is epsilon 0 E plus epsilon 0 chi E. Epsilon 0 is taken out, 1 plus epsilon 0 1 plus XE. Epsilon 0 Ke. That is K is epsilon R is equal to K equal to 1 plus chi E. 1 plus chi E. And that is the dielectric constant of the material. So there may be a question like this. Give an expression for dielectric constant in terms of electric susceptibility. Give an expression for dielectric constant in terms of electric susceptibility. The relation is K is 1 plus chi E, or epsilon R is 1 plus chi E. And here comes a problem. You see the problem. Show that the force between two charges separated by a distance is reduced by a factor 1 by 1 plus P by epsilon 0 E due to the presence of a dielectric. The problem is show that the force between two charges separated by a distance is reduced by a factor 1 by 1 plus P by epsilon 0 E due to the presence of a dielectric. ഡയലക്ട്രിക്കിൻ്റെ സാന്നിധ്യത്തിൽ രണ്ട് ചാർജ് തമ്മിലുള്ള ഫോഴ്സ് ഇത്രയും കണ്ട് കുറയും, ഡിക്രീസ്ഡ്. ഈ 1 by 1 plus P by epsilon 0 E എന്നുള്ള ഫാക്ടർ കണ്ട് കുറയും എന്ന് തെളിയിക്കുക. And you know the force between two charges Q1 and Q2 separated by distance D is given by F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by D square. When dielectric is introduced, epsilon 0 we have to replace by epsilon 0 K or epsilon 0 epsilon R. When a dielectric medium of constant K is introduced between the two charges, the force F dash between them is given by dielectric medium വെക്കുമ്പോൾ force decrease ചെയ്യും. Then F dash is equal to 1 by 4 pi K epsilon 0 Q1 Q2 by D square. Except K, the remaining is F. Therefore, F dash we can write as F by K. But we have seen polarization vector P is epsilon 0 E into K minus 1. Or from this we get K is 1 plus P by epsilon 0 E that we put in the above equation for F dash. F dash is F by 1 plus P by epsilon 0 E. That is force is reduced by a factor 1 plus P by epsilon 0. അതായത് നമ്മൾ കെയുടെ വാല്യൂ ഇവിടെ 1 പ്ലസ് പി ബൈ എപ്സിലോൺ 0 ഇ എന്ന് കണ്ടുപിടിച്ചു. ആ വാല്യൂ നമ്മൾ മുകളിലത്തെ ഇക്വേഷനകത്ത്, അതായത് എഫ് ഡാഷ് ഈക്വൽ ടു എഫ് ബൈ കെയുടെ അകത്ത് കൊടുക്കുമ്പോൾ നമുക്ക് കിട്ടുന്നത് എഫ് ഡാഷ് ഈക്വൽ എഫ് ബൈ 1 പ്ലസ് പി ബൈ എപ്സിലോൺ 0 ഇ. ഇത് എന്താണ് തെളിയിക്കുന്നത്? ഫോഴ്സ്, പുതിയ ഫോഴ്സ്, ചാർജുകൾ തമ്മിലുള്ള പുതിയ ഫോഴ്സ്, ഡൈലക്ട്രിക് മീഡിയം വെക്കുമ്പോഴുള്ള ഫോഴ്സ് നേരത്തെ ഉള്ളതിൻ്റെ 1 പ്ലസ് പി ബൈ എപ്സിലോൺ 0 ഇ കണ്ട് റെഡ്യൂസ് ചെയ്യും. Next problem. The dielectric constant of water is 78. Calculate the electrical permittivity. Very simple question, but important. The dielectric constant of water is 78. Calculate its electrical permittivity. Epsilon is epsilon 0 r, epsilon 0 epsilon r, or epsilon is k epsilon 0. K is 78, and epsilon 0 you know, 8.85 into 10 raised to minus 12. The answer is 690.3 into 10 raised to minus 12 farad meter raised to minus 1. Next problem. The dielectric constant of a medium is 4. Electric field of the dielectric is 10 raised to 6 voltmeter raised to minus 1. Calculate electric displacement and polarization. Here epsilon r or k is 4. The field is 10 raised to 6. D and P we have to find. D is epsilon E or k epsilon 0 E or epsilon r epsilon 0 E. That is 4 into 8.85 into 10 raised to minus 12 into 10 raised to 6 field. The answer is 35 into 10 raised to minus 6 coulomb meter raised to minus 2. And now comes the polarization. P is k minus 1 epsilon r minus 1 epsilon 0 E. K minus 1 epsilon 0 E. That is 4 minus 1 into 8.85 into 10 raised to minus 12 into 10 raised to 6 equal to 26.55 into 10 raised to minus 6 coulomb meter raised to minus 2. Now comes example 4. Next problem. The dielectric constant of neon gas at NTP is 1.000134. Calculate the dipole moment induced in each atom of the gas when it is placed in an electric field of intensity 9000 voltmeter raised to minus 1. Also find the atomic polarizability of neon. Epsilon 0 is given, Avogadro number is given, and here you note Avogadro number is 6.023 10 raised to 26. That is atoms, kilogram mole raised to minus 1. ഒരു മോളിനകത്തുള്ളതാണ്. Actually, if mole is taken, if a gram molecule is taken, mole is taken, then Avogadro number is 6.023 into 10 raised to 23. So if we take 10 raised to 23, we have to take a molecular weight in gram. And if we take the molecular weight in kilogram, we have to write 26. When you take Avogadro number, you must be very careful. ഈ Avogadro number ശരിക്കും നമ്മൾ പഠിക്കുന്നത് 6.023 into 10 raised to 23 atoms per mole എന്നാണ് പഠിക്കുന്നത്. Atoms per mole എന്നാണ് നമ്മൾ പഠിക്കുന്നത്. പക്ഷേ അത് കിലോഗ്രാം മോളാക്കുമ്പോൾ ഈ ഗ്രാം കിലോഗ്രാം എന്നുള്ള കൺവേർഷനിൽ ഒരു 10 raised to 3 വരുന്നതുകൊണ്ടാണ് ഇവിടെ 10 raised to 26 ആകുന്നത്. അത് ആ പ്രോബ്ലത്തിൽ എന്ത് മാറ്റം വരുത്തും, അല്ലെ എങ്ങനെയാണത് അപ്ലൈ ചെയ്യുന്നത് നോക്കാം നമുക്ക്. Let n be the number of neon atoms per meter cubed and small p the dipole moment induced in each neon atom. Then the electric polarization is given by നമ്മൾ നേരത്തെ പഠിച്ച റിലേഷൻ തന്നെ. Capital P is small n into P. Small n is the number of dipoles per unit volume and small p is the dipole moment. It is equal to epsilon r minus 1 or k minus 1 epsilon 0 E. We have written the expression for polarization. That relation is repeated. K is NB, k minus 1 epsilon 0 E or P. P is equal to the dipole moment, small p is equal to k minus 1 epsilon 0 E by N. And you remember, K is given 1.000134 is 90,000 voltmeter raised to minus 1 and N. That you know, mass by volume, molecular weight by molar volume. Molecular weight by molar volume. N is the number of atoms per mole. So we write Avogadro number by the molar volume, M by V. N by V. Or it is n rho by M. Another equation is n rho by M we have studied. Here rho by M is M by rho is volume. Molar volume is coming below. So here we need only use the equation capital N by V. Capital Avogadro number by molar volume. That is number of small n, number of atoms per mole. Number of atoms at unit mole. I repeat, n is the number of atoms in unit volume. 6.023 into 10 raised 26 is the number of atoms in molar volume. In liters, when we say in liter, actually it is, you remember, small n is 6.023 into 10 raised 23 by molar volume, 22.4 liters. Liters, when we convert to meter cube, 24.4 into 10 raised to minus 3. And when this 10 raised to minus 3 comes to the top, we get 10 raised to 26. Or when we take Avogadro number as 6.023 into 10 raised to 26, we need only write volume in liters just below. Need not convert meter cubed. ഇത് വളരെ ശ്രദ്ധിക്കേണ്ട ഒരു കാര്യമാണ്. ഈ സ്മോൾ എൻ എന്ന് പറഞ്ഞാൽ ക്യാപിറ്റൽ എൻ ബൈ വി ആണല്ലോ. ക്യാപിറ്റൽ എൻ എന്ന് പറയുന്നത് 6.023 10⁻23 ആണ് ഒരു മോളിൽ. പോളാർ വോളിയം എന്ന് പറഞ്ഞാൽ 22.4 ലിറ്റേഴ്സാണ്. ആ ലിറ്റേഴ്സിൻ്റെ മീറ്റർ ക്യൂബിഡ് ആകണം നേരം 24.4 10⁻³ അവ രണ്ട് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ ഇതുപോലെ കിട്ടും. അല്ലെങ്കിൽ അവഗാഡ്രോ നമ്പർ 6.023 into 10⁻26 എടുത്താൽ താഴെയുള്ള വോളിയം 22.4 ലിറ്റേഴ്സ് തന്നെ എഴുതണം, കൺവേർട്ട് ചെയ്യരുത്. അപ്പോൾ എളുപ്പം, ഇതിനേക്കാൾ കുറച്ച് എളുപ്പം ഞാൻ പറഞ്ഞതുപോലെ പഠിക്കുന്ന സ്മോൾ എൻ ഈസ് ക്യാപിറ്റൽ എൻ ബൈ വി, ക്യാപിറ്റൽ എൻ ഈസ് ദ യൂഷ്വൽ വാല്യൂ ഗിവൺ ഇൻ ദ ടേബിൾ 6.023 into 10⁻23 per mole. Molar volume is 22.4 liters, that is 22.4 into 10⁻³ Then we get this answer, 2.69 into 10⁻25. Substituting these values in equation 1. Substituting these values in equation 1. These values in equation 1, dipole moment is small p is equal to 1.000134 minus 1 into 8.85 into 10⁻12 into 90,000 by 2.69 into 10⁻25, 3.97 into 10⁻, it is 25 will go up, we get minus 12, then p is equal to 10⁻, that power you verify, it is power you verify, minus 25 will go up, it is 36 is written. You see whether 36 will come or not. ഇവിടെ 10⁻12 മുകളിലുണ്ട്. അപ്പോൾ അത് ചിലപ്പോൾ 16 ആയിക്കൂടാനില്ല. ആ പവറിനൊരു മിസ്റ്റേക്ക് ഉണ്ട്. You look there, you calculate and correct the power. അപ്പോൾ ആ പവർ താഴെയും ചെയ്തിരിക്കുന്നത്. അപ്പോൾ അവിടെ ഒരു കറക്ഷൻ വരാൻ സാധ്യതയുണ്ട്. ഉണ്ടോ നോക്കുക. The atomic possibility is given by alpha is equal to p by epsilon u. The atomic possibility p is equal to alpha e. Dipole moment by e. Therefore, 3.97 into 10⁻36. Oh, it is minus 36. That is minus is missing. So in dipole moment 3.97 into 10⁻, the minus is not evident there. Minus 36. That is true. When this 25 will, when this 25 goes up, it is minus 25. There is minus 12, which is equal to minus 37, and there is 90,000 altogether. Altogether, you will get this value minus 36 3.97 into 10 raised to minus 36 coulometer, and that is put here. We get 4.4 into 10 raised to minus 41 coulomb meter square volt raised to minus 1. That is the atomic polarizability. To calculate atomic polarizability, we have the user relation. Small p dipole moment is alpha E, alpha A or alpha E. Alpha is the atomic polarizability. That is all with your 46th lecture on solid state physics. That is all. Thank you very much.